Welcome back to Pathashala, your one-stop learning place for simple and smart education. And if you are new here, please don't forget to subscribe and hit the bell icon so you never miss learning updates. And as you all know, we are going on with the class 9 mathematics chapter 1, the number system. We have finished with the introduction concepts, the key concepts. Now we are moving on to the exercise problems. Exercise 1.1. Let's see the first problem. The first problem is 0 a rational number? Can you write it in the form of p by q, where p and q are integers and q not equal to 0? They are asking whether the 0 is a rational number. If it is a rational number, can it be written in the form of p by q? With the condition, the q must not be equal to 0. The answer for this is yes, because 0 is a rational number. 0 is a rational number. Why it is rational number? Because it can be represented in the form of either 0 by 1 or 0 by 2 or 0 by 3 and so on. So we can represent the 0 as 0 by 1, 0 by 2 or 0 by 3. The answers will be 0 only. So answer is S. 0 is a rational number because it can be represented in the form of p by q, where q is not equal to 0. Where q here is 1, the q here is 2 and the q here is 3. Now we move on to the next problem. The second one, find 6 rational numbers between 3 and 4. We need to find 6 rational numbers between 3 and 4. We know rational numbers are expressed in the form of p by q. 3 is also a rational number because by default 1 is present in the denominator. 4 is also a rational number because 1 is there in the denominator by default. So how to find the 6 rational numbers between 3 and 4? So we might write like 3.1, 3.2, 3.3, but these are not rational numbers, these are decimals. So how we can find out the rational numbers? We have a easy method to find out, the shortcut method to find out those rational numbers. What is that shortcut method is? So they are asking 6 rational numbers. So for the 6 rational number, what we have to do is we need to add 1 to that 6. If they have asked for 7 rational numbers, we need to add 1 to the 7. If they have asked for 8 rational numbers, it will be 8 plus 1. If they have asked 9 rational numbers, it will be 9 plus 1. Now they have asked for 6 rational numbers, so we need to increase that number by 1. 6 plus 1 is 7. This is the step 1. In the step 2, the number 3 and number 4, we need to multiply as well as divide the number 7. For this number also, we need to multiply and divide the number 7. What we will get? 3 sevens are 21 by 7. 4 sevens are 28 by 7. So what we did is just a equivalent expressions, because if we simplify these 21 by 7, 7 ones are, 7 threes are, we will get back the original number. In the same way, if we simplify this 28 by 7, we will get back the original number 4. So now we can easily find out the rational numbers between 21 by 7 and 28 by 7. So we will find out those. The first number will be 21 by 7 and the last will be 28 by 7. So what are the numbers we will get? 22 by 7, 23 by 7, 24 by 7, 25 by 7, 26 by 7, 27 by 7 and 28 by 7. So these two are the given numbers. This is nothing but number 4. So what are the 6 actual rational numbers between 3 and 4? 22 by 7, 23 by 7, 24 by 7, 25 by 7, 26 by 7 and 27 by 7. In case if are in a simplified form, we can simplify those numbers and we can write the answer. So now these cannot be simplified, so we can write the answer as it is. Now we move on to the next problem. Find 5 rational numbers between 3 by 5 and 4 by 5. So now we need to find out the 5 rational numbers between 3 by 5 and 4 by 5. So in the previous problem, what they have given? They have asked for 6 rational numbers between 3 and 4. They have given only 3 and 4. So what are the denominator of those numbers? So the denominators were same. So here also denominators are same. Only in this cases we can use that shortcut method. What is that shortcut method? How many rational number they have asked? We need to add 1 to that number. So they have asked for 5 rational number. So we need to add 1 to that 5. If they have asked 6 rational number, 6 plus 1. Only in the case of the denominators are same. Only when the denominators are same, we can use this method. So please keep that in mind. So now we need to find out 5 rational numbers between 3 by 5 and 4 by 5. Here also denominators are same. So 5 plus 1 is 6. What we need to do? We need to take the first number 3 by 5 and we need to multiply and divide the number 6. Now take the second number and do the same thing. Multiply and divide the number 6. 3 6 are 18 and 5 6 are 30. 4 6 are 24. 5 6 are 30. So now we can write the rational numbers between 18 by 30 and 24 by 30. The first number is 18 by 30. The last number is 24 by 30. What are the numbers we'll get in between these two? 19 by 30, 20 by 30, 21 by 30, 22 by 30, 23 by 30 and 24 by 30. So we got a rational numbers between these two. How many we got? Except the starting one and the last one. We got 1, 2, 3, 4, 5. We got 5 rational numbers. Here we can simplify this 20 by 30 as 2 by 3. And this also we can simplify with a we can cancel it with a 2 ones are table, that is 2 11s are 22 and 2 15s are 30. So we can write the answer as it is or we can write it in the simplified form. 19 by 30, if we cancel 0 and 0, it will be 2 by 3, 21 by 30 as it is, and 2 11s are and 2 15s are 23 by 30. We can write this also as an answer. So 19 by 30, 2 by 3, 21 by 30, 11 by 15 and 23 by 30. These are the 5 rational numbers between 3 by 5 and 4 by 5. So we have seen the problems with the same denominators. For example, if they are given the problems with the different denominators. For example, it is not 3 by 5 and 4 by 5. It will be 2 by 5 and 3 by 4. So this is not the exercise problem. This is for example I have taken. So 2 by 5, here the denominator is 5 and here the denominator is 4. So what we have to do in this case? We can't add this, we can't add 5 plus 1 is equal to 6 because denominators are different here. What we need to do is, we need to take the first number, then take the second number as well. What we need to do to the first number is take the second number's denominator and multiply and divide with the same number. So you have to take the first number as it is and take the second number's denominator, multiply and divide with the first number. So in the same way, for the second number, take the first number's denominator, that is 5, multiply and divide 5 for the second number. So repeating once again. So what we need to do is, for the first number, you have to multiply and divide second number's denominator. For the second number, you need to multiply and divide the first number's denominator. So what we'll get? 2 4s are 8, 5 4s are 20, 3 5s are 50 and 4 5s are 20. Now the denominators become same. So now we can write the rational numbers between these two numbers. What's the first number? It's 8 by 20 and the last number is 15 by 20. So we can write the numbers between these two, that's 9 by 20, 10 by 20, 11 by 20, so until 15 by 20. So this is in the case of different denominators. Now we will move on to the next problem. So we are moving on to the last problem of the exercise 1.1. Fourth question. So we need to tell whether it's true or false with the explanation. The first statement is every natural number is a whole number. So every natural number is a whole number. The answer is true. Because we know what are whole numbers. Whole numbers starts from 0, 1, 2, 3, 4 till infinity. What are natural numbers? Natural numbers starts from 1, 2, 3, 4 till infinity. So as we can see here, so natural numbers starts from 1. So the whole number contains all the natural numbers. So every natural number is a whole number. The statement is true. Second one, every integer is a whole number. We know what are whole numbers. Whole number starts from 0, 1, 2, 3, 4 till infinity. What are integers? Integers are the collection of numbers which contains whole numbers as well as negative natural numbers. That is minus 3, minus 2, minus 1, comma 0, 1, comma 2, comma 3 and it goes on. So it goes on towards positive also, it goes on towards negative also. But the whole numbers have only the positive numbers. These negative numbers doesn't come in the whole numbers. So the statement is false. Every integer number is not a whole number. So whole numbers are only the positive numbers. The third one is every rational number is a whole number. Every rational number is a whole number. What are rational numbers? The numbers which can be expressed in P by Q. So what are whole numbers? Whole numbers are the numbers which doesn't contain any decimals or fractions. So if the statement is actually false, we'll write the answer first. I'll explain why it is false. Every rational number is not a whole number. Why it's not a whole number? Let's take an example. Take a fraction of 4 by 2. This is a rational number. Okay. The 4 will be divided completely by 2. What is the answer for 4 by 2? Is 2. Yes, this rational number is a whole number. So let's take another one. If it is 5 by 2. So 5 will not be divided completely by 2. We will get a remainder. So we will not get a whole number. So every rational number will not be a whole number. We may get a whole numbers for some rational numbers. So this statement is false. Every rational number is not a whole number. That's all for today's class. If you found this video helpful, please do like, share and subscribe to Pathashala. Keep learning, keep growing. I'll see you in the next class. Thank you.